I can touch it, it's not going to go in my soft tissue. I don't have to worry about it shattering and getting glass shards. That means I can work with it in the field, and I don't have to worry about specialty protective equipment. Okay? I can handle it. I touch it with my skin. The other nice thing is, at no point is glass ever getting dirty because it's, again, encased in polymer. So I don't have to polish this, I don't have to clean it, I don't have to do any of that with these modern cables. But the most impressive thing, this is where I always get people's attention, those polymers also don't let the glass break. So you can tie these modern fibers in knots. They're incredibly strong. In fact, they have what's known as a micro bend radius. You'd never see this with a traditional fiber. You have a bend radius of about 30 millimeters. This is 3 millimeters. It's actually smaller than the jacket itself. So for us low voltage professionals who tie cables on the back of our cars to pull them through conduit, you can handle fiber cables. We can handle fiber cables roughly in the field. Okay? Now don't get me wrong. You can get these fiber cables to crack. This is another really nice thing. So if I really work, and I can get it to break. If you really work at this, you will get it to break. Okay? And actually, usually what happens is when guys will terminate for the first time, they'll squeeze this strand too hard, and then it'll break, but you still don't have to worry about glass shards because, again, that polymer holds it together so you don't get shards. It just breaks in a stick, a big stick. But if I really work at this, I will get this fiber to crack, and you'll see light loss in the jacket. But what that polymer does is when you get a crack in the fiber, and then I straighten it back out, it just corrects itself. So it's not like a traditional fiber, because you were lucky if you were pulling a traditional fiber and it broke, you know, a solid break in it, because then you knew you had a bad line. What tended to happen with the traditional fiber is if you get a crack in it, over time that crack would gradually spread and your fiber would gradually degrade. So a lot of guys that go on site, you know, they're working with a fiber run that's been there for years, they'll tone it out, you know, they'll meter it out and they'll say, man, I'm just not getting any performance out of this fiber line. Often that's because there's a crack in it that's just spreading and that fiber's falling apart. You don't have that issue with these modern fibers, okay? And now this is a very unique patent. There's not many companies that are working with it. But in my opinion, again, this is what makes fiber very deployable in our world. Because again, it's low cost to get into it and you can handle it really roughly. Okay? Yeah.
Now, with the bend radius on that, will that affect the signal with that fiber?
You will have loss. So it's not going to necessarily affect the signal per se unless you have too much loss on that run where now you're just not having good signal going back and forth between your devices. So the course, and you again, you can watch the course online, the troubleshooting course, we talk about link budget. And what the link budget is how much loss can my devices tolerate before they don't work anymore, and how many things do I have in line, like fiber tied in a knot, that are creating loss. So with that knot tied in there, if I was to take a meter and actually, you know, dB that out, meter it out, I'd probably see that I have 2 dB of loss, right? Most HDMI extenders, which are the most fickle products you'll get out there for fiber, they handle about 3 dB of loss before they start to lose sync. Okay, so there's even a white paper. If you go to the web and just type in troubleshooting fiber or link budget, you'll see an article that talks all about this. But the punchline is, yeah, it's not ideal to tie knots in your fiber, right? Are you going to do that? Yeah, are you going to do that in the real world? No, but what you are going to do is you're going to come up out of a box. You're going to have a bend radius like this going into another pipe. You know, you're going to kink it during the pull. It's going to kink during the pull, right? But you're gonna, you know, you're gonna correct all that kind of stuff. You don't have to worry about this stuff getting trashed during the pull. Okay? All right. Let me turn that off. We'll come back to this here in a minute. Before we do that, again, let me reinforce, Simplex Fiber, 1 strand. Very often in the telecom world, you will see Simplex Fiber getting pulled to the demarc. Singlemode, we'll talk about that here in a minute. A lot of guys will ask me, if you only have 1 strand, is it just one-way communication? right? You can have bidirectional communication on one strand. It's just the lasers, the optical engines, and the wavelengths that are shooting in the two different directions. That, different wavelengths can go in different directions. It just tends not to be the common way we design electronics. And really, even though this is new to so many people in our world, this technology, network technology, fiber optic technology, it's been around for a long time. So the more that manufacturers like myself can use standard networking stuff, the faster we can race the prices down on the equipment. So we try to incorporate as much standards into our electronics as possible. Now what you will likely be using more often than not, duplex fiber, 2 strands. This is the bread and butter, man. This is what you pull day in, day out. This is what you're gonna use for networking, AV distribution. Most pre-wires are getting a duplex run, to all the different points. The most common one is going to be riser rated. It's about 39 cents a foot. I tell everybody, this is another one of those disruptive technologies, right? We've seen this before with HDMI when everybody went from component video to HDMI. For people who are in business then, what happened when we made that shift? We all made money. There's a lot of margin anytime you see a technology shift. Fiber is no different. I do these classes literally all over the world. Across the United States, the average price, or the average markup on fiber, that 39 cents a foot cable that you're buying, $1.50, $2 a foot all day long. You can make money on this, don't give it away. There's no sense in giving it away. Those breakout fibers, again, heavier jacket on each one of those strands inside an overall jacket, okay? This is different than the micro distribution, which is individual strands, less jacketing inside a heavier jacket. That's where we get those heavy strand counts, those high strand counts in a really tiny little cable. So how do we work with that? Well, right, if we're talking about fiber, if we're talking about wiring, cabling infrastructures, we got to have wall plates, rack panels, wall boxes, demarc boxes, all of this stuff exists. So what you typically do, and you'll see this, so like rack trays and stuff that we sell and we build, you always have these coilers inside there. Now it's not that big of a deal with our fiber because you have that micro bend radius. But let's be real, you're going to go into installations where other fiber's been pulled. You gotta handle it carefully. You wanna make sure you have those bend radiuses, and the fiber optic equipment always has these coilers to make sure you never exceed the bend radius on the traditional fiber so it doesn't break. And then you take your individual strands and then you break this out into your panels, your little patch panels. Okay, so what I would do is I'd take my multi-strand cable, break out those individual strands, put my connectors on, and then go into the individual ports on my breakout panels, whether it's a wall box or a rack tray, and then from there I can go into my different devices, whatever they may be. We even make fan out cables that will do this kind of stuff for you. It all depends on how you like to wire, okay? Single mode versus multi-mode. There are 2 different types of fiber you are going to encounter, okay? Again, we talk about standards. So these cables are color coded. If you go into an installation and you see a yellow cable, it's a single mode fiber. If you see an aqua colored, just like what we have, it's a multi-mode cable. TechLogix is probably one of the first companies to actually deviate from these standard color codings because we just launched a line of black fiber optic cables because we've had so many integrators say, I don't want color on my racks. They got them all blend into all the AV equipment. So we're building patch cords that just have a tactical black jacket on them now. But in the fiber world, you will see these 2 colors, yellow, aqua. And here's the difference between the 2 cables. Single mode fiber is used for long distance distribution. Okay, and this is counterintuitive, okay? When we think about a copper-based cable, how do you send more voltage? Well, you increase the thickness, the gauge of the cable. How do you go longer distance? You increase the thickness, the gauge of the cable. Fiber is the opposite. How do you go longer distance? You have a smaller piece of fiber in there. okay? So a single mode fiber cable has a smaller core of glass in it. And that drives your signals up to 20 kilometers. So you could come to us and say, man, I got this really long run that I'm looking at pulling. I need 20 kilometer, 12 mile pull of cable. We can do that if you want it. We don't, I think the longest pull that we've seen is like about a mile, 5,000 feet. Because we don't sell into a lot of the, underground telecom. But we sell into Las Vegas. I'll tell you, that's a massive market. You go into those casinos, they have mile runs of single mode cable. And single mode is made to go those distances. Now in the commercial world, a lot of guys just standardize on single mode. They'll have their patch cords that are like 3 feet. They'll have their long cable runs. Single mode can be any length you want it to be. Multi-mode is the one that maxes out at about 1,000 feet. Why is that? Okay? Again, it goes down to that core size. So if we look inside the cable at the glass, that multi-mode cable has a thicker piece of glass in it. And a thicker piece of glass allows you to send more simultaneous signals. So I can easily, we'll talk about bandwidth here in a minute, but I can easily use that one multi-mode cable to do my networking, my AV, my control, everything over that one cable. The problem is that if you got a bigger pipe and you got these waves of light, these lasers bouncing through that pipe, over distance they start to get out of phase. So what'll happen is you get out of phase, your signals fall apart. That happens at about 1,000 feet, okay? Single mode fiber, that pipe's 9 micron. It's much smaller, right? You go from a 50 micron to a 9 micron cable. Now we keep those signals in phase at 20 kilometers. And we literally make these extenders $450. You can take your HDR signal and go 20 kilometers if you want. And we do that kind of stuff in casinos. Again, a massive market for fiber optic technology. Okay? We see most people pulling multi-mode fiber. And this is a little counterintuitive too, because when you'll look at the price sheet or you'll get a fiber quote, you'll look at a single mode price and often it's actually less expensive. There's less glass in a single mode cable, so the cable's actually less. And guys will say, well, why don't I just do single mode for everything? You can. You get the same bandwidth capabilities really out of the two cables, but here's the problem. The electronics to create an optical engine that has that much smaller lens tends to cost more money. So while you're saving a little bit on the cable, you're going to be spending more on the electronics. And that's where most people look at this and say, if I'm under 1,000 feet, I'm just going to do multi-mode. The one piece of advice I'd give to you is, if you're doing residential, it's almost all multi-mode. But if you're getting into these commercial environments where you already have single mode installed, or you're going to have some bigger runs, just stick with one type. That way you don't have to try to convert one type of fiber to the other, because they're different core sizes. You can't take a multi-mode, a bigger piece of glass, and just passively stick it on a smaller piece of glass. It doesn't work. You got to have electronics that do that. The lenses are different sizes. Stick with one type of fiber. Now in the residential world, you always have single mode going into that demarc. That is what you will have. But at the demarc, you always get that step down into a modem, and then you're going into your network switches. So you can step through that modem, step it from single mode into multi-mode by just throwing a multi-mode SFP fiber module on it. Okay? If you're extending the demarc, that's a different conversation. You're going to take your single mode fiber, extend the single mode with another piece of single mode, and then wherever you have your modem, step it into multi-mode. Okay? Tend to stick with one type of glass. Now I always include this slide. It's a misleading slide, but I include it because often I have folks who come from the Bixby world, and in the Bixby world we talk about again a lot of the standards. They have seen charts like this before, so I always want to address it because I get questions on it. There's a couple of things going on. Let me explain here, and I'll explain why it's misleading. So first of all, fiber comes in different grades. OM is optical multimode. OM1, OM2, OM3, OM4. That pertains to the quality of glass. Okay, an OM1 cable, you don't see a lot of OM1 cable anymore. it was pulled. It's a 62 micron cable. It's a bigger, thicker piece of glass. We don't pull it anymore. And if you're trying to buy fiber and you get a quote and find OM1's really cheap, that's because someone's trying to dump that off on you, right? And odds are there's probably a crack in it, so don't buy it. It's older glass. Most people who are pulling fiber today are OM3, OM4. We don't even really sell OM2. We'll make it for you if you want it, but OM3 and OM4 are about the same price just because so much of it's being made now. OS, optical single mode, that actually, those gradings pertain to the construction of the cable. It's not a big deal with the SSF grade like what we just saw, but in traditional fiber, one of the issues you had is an OS1 cable, which is a tight buffered cable, meaning that the jacket is really rigidly jacketed on the fiber strand. What could happen is if you had that in like underground conduit and you had a freeze cycle, you'd have a compression on the cable and then it would thaw, it would release, it would compress during the next freeze cycle. What would happen on an OS1 or a tight buffered cable is it would crack the fiber, okay? So traditional fiber, you didn't see a lot of OS1 because if it wasn't temperature controlled, you get cracks in your fiber. So people would use an OS2, which is a loose tube. So when you come to us to buy like bulk fiber, we tend to standardize on loose tube. Again, SSF doesn't really break like that, but OS2 tends to be the standard in the industry now, okay? But that pertains to the construction cycle, or the construction's how we build our cable. Now, the rest of what you're seeing, this is where it's misleading, because in the Bixby world, you will have a bandwidth rating, okay, and then you will have a distance rating. These charts don't just look at the glass bandwidth capability. They also take into account the electronics. And the weakest link in any installation you will do is the electronics. Simply put, electronics have not been able to fully harness the properties of the glass. These glass cables, so if you pull this cable right here off the shelf, I mean you buy pre-made $10, this cable has 100 petagigs worth of data capability. 10,000 times more data capability than a Cat6 cable. You have all the bandwidth potential in the world in the cable. The electronics are what holds it back. You can only do so much with those optical engines in the electronics, whether it's networking equipment, whether it's AV equipment. That's what continues to evolve. So these charts you see that have bandwidth at a certain distance, it's a moving target. You will see new technology continually come out. As those new electronics come out, you can push your bandwidth further, you know, start to harness the glass. The punchline is, you pull fiber, put your OM3 in, put your OM4 in, you are future-proofing. This cable has the bandwidth capabilities. Because you're putting in a bulk piece of glass, you can upgrade what's on the end of that cable as new versions of HDMI come out, as new network switching equipment comes out. The cable never change, just the things on the ends of it will change. Okay, it allows you to upsell. Make sense? Good? All right, let's talk about connectors. So, different types of fiber. They all use the same types of connectors. There are a variety of connectors out there. Now the good news is, in our world, AV, datacom, low voltage, we really only deal with two. LC and SC style connectors. The biggest difference between the two is simply the size. The optical lenses inside of them are the same. The physical, properties, the performance of the two are the same. If you can terminate one, you can terminate the other. Same equipment's used for termination. The difference is really in the size. LC are a smaller connector. They're also slightly more expensive because there is a Lucent patent. These were developed by Lucent Technologies for SFP modules and networking. Because they're smaller, you can fit more of them on your devices, more connections on your devices, and you can make the devices smaller. Us manufacturers tend to use LC connectors now because we'll use these standard networking modules, right? If you've ever done a fiber switch, you see this little module, right? You pop it into the fiber port. Well, the LC connector clicks into that port. That's what the LC does, okay? The SC style, and today, by the way, I always train guys with the the SC style, this one, the bigger one, because one, they're less expensive, so as we use them, we're saving a little bit of money, because often, I go through a lot of these connectors. By the way, these are reusable. These connectors that I'm using today have probably been re-terminated 50 times plus. I've already done, this is my 4th training this week. So we use the bigger ones, but it will also allow you to hold them easier. You'll see what's happening, everything's bigger on it, okay? These connectors tend to be used in the older blade servers, okay? But most of the electronics manufacturers have been shifting into the LC. Now, if you encounter, one in the field and you need the other one, you can get crossover cables. You can buy couplers that convert from one to, we do all of that kind of stuff. Again, you're not sacrificing performance one to the other. It's really, what kind of electronics am I putting in? If it's a media converter, maybe it uses an SC. If it's a network switch, maybe it uses an LC. Terminate your fiber when you know what you're going to be plugging into it. If you're doing an installation, I tell a lot of guys, don't even terminate it. Leave that fiber, leave it dark. Don't light it up. Leave it dark until you're ready to put the electronics on the end and then terminate it. Unless your homeowner or your business owner requires you to, then put an LC connector on it. That tends to be the standard, okay? So let me show you how this works. So again, let's go back to our fiber. Here's our fiber. Let me light this fiber up. All right, so these connectors, there's really 3 different parts to this connector. If I open it up, and the easiest way to open these things up is just to pop them on the table. The first thing you have is your outer shroud. This is the part that actually connects to your network switch inside the port. The next part of the connector is the boot. This is what holds the connector onto your cable. I just unscrew that, and now I have the connector itself. This is the most interesting part. So these connectors are what are known as mechanical connectors. They're hinged, so I can open this up. You'll see a little V-groove in there, right? There's a little V-groove inside this connector. This is where we slide the fiber in. And I'm going to walk around and show everybody so you can see it even easier. I'm going to show you with the fiber in it, so it's going to light up the connector. So, but before I do that, I have to, remember, cleave my fiber. I'm going to show you what happens when you cleave it. So remember I talked about when you cut fiber, you don't do it with the Kevlar shears or a snip, because when I take a Kevlar shears to it, you see how that lit up? Well, the reason that's lighting up is because I'm crushing the tip, and lasers need to, the light needs to come through here, and it needs to pass cleanly into the optical lens of my connector and my devices. Well, when I take the Kevlar shears, like I trim it coming out of the box, you're crushing the end. You have breaks and fractures in the end. So the cleaver, I'm going to go ahead and take my cleaver. Let's do it here so you guys can kind of see. My cleaver, let me open that, it's magnetic. My cleaver is going to take the glass, score it, and snap it. And now watch what happens. I'll hold this up here. So you see the light goes out, right? The light is not out, the light's there. This is a nice clean cut piece of fiber. All I did is place it across my cleaver wall, or my cleaver wheel, ran the cleaver wheel across it, it scored it, it snapped it. That's what the cleaver does. Nice clean break. You don't see the end all lit up now. It's a nice clean break. Now this piece of glass is ready to go in my connector. Okay? So if I was doing this from start to finish, I'm probably in this whole process for 30 seconds. Take off the jacket, strip off that soft peel. You're not spending a whole lot of time. So what we do now is we take our fiber, now that it's cleanly cleaved, and we slide it into this V-groove on my connector. You see my connector's lit up? So there's a couple of things on this connector that I'll point out. So the fiber just slides right into that connector, into the V-groove. Now these connectors will tell you if it's in there all the way. See, there's this little window. You'll see this yellow window as I walk around. That's actually an optical window that locks the fiber in place. So I mentioned these connectors are reusable. By sliding this window forward, there's a tab, I slide it forward, it grabs the fiber, pulls it into the lens, and locks it in place. So at any given moment, I can unlock my fiber, reseat it, put my connector on a different piece of fiber, but basically these are reusable. Okay? So terminating this fiber is really as simple as take off your jacket, take off the coating with your fingers, cleave it, slide your fiber into the connector, lock it in place. Okay? And if I wanted to finish this whole thing off, and again, I can take my connectors off, I can reseat it. The optical lens is going to tell you if you have a good connection or not, and it does that by how much light loss you have. Right? If my fiber is not fully seated, that's what happens. Basically, the lasers go into the connector, hit a gel pocket, and it lights the connector up like a Christmas tree. This is why the VFL is so important, because when you plug that VFL into your connector, it will tell you, you got a bad connection. You're not lighting up the tip, you're lighting up the gel pocket. So unlock your connector, right? Take it off, slide it back into your connector, make sure it hits that optical lens, light it or lock it in place, and now you're putting all of your laser into that tip. And from, you know, really it's that simple. So I'm gonna go ahead, take my boot, put my boot on the cable, I'm gonna slide my fiber into my connector. I'm gonna lock it in place. Some guys will cut the Kevlar off right away. I do not cut my Kevlar off right away. I actually leave it on there because it gives you a little strain relief when you take the boot and you start to screw that boot on. Get some of that Kevlar into the actual grooves. After I give it a couple of twists, I cut my Kevlar off. And that's it. That's how you terminate fiber. So you can do this reliably in a minute. There's really no secret to this anymore. And it used to be that you had to have fusion splicers and polishing and everything. These modern fiber optics, you know, because of the gels that are in here, and you get about 12 termination cycles out of these connectors, you know, before you've removed enough gel. And actually this connector, I mean, I wouldn't use this connector in an installation just because I use it for training, so I'm always pulling it in and out. But you get about 12 cycles out of a brand new connector. Okay? If you can't do this with 12 tries, you might want to reevaluate. Yeah, you might want to reevaluate. All right, so that's connectors. That's how you put it on the cable. It's really not that difficult. Hardest part is taking that soft peel off because, you know, a lot of guys will squeeze it too much. And then it's making sure you seat that fiber in there. Okay, one other thing, I don't have a slide on this, but I'll just talk about it right now. So if you're doing an installation, there's two things that will really sync your project. There's more than two things, but the two major things that are gonna get you is not seating your connectors. So when somebody calls us up and says, man, just my extenders aren't working, or my Networx switch isn't working, what's going on? What's the problem? The big thing is making sure your connectors are fully seated. And we'll always have the folks open up their connector, look at that window. Is it lit up like a Christmas tree bulb? If it is, reseat your connector, okay? But the other thing, fiber optic equipment, when you buy the electronics, when you buy the connectors, they all come with dust caps, okay? Most people overlook this. They come with dust caps for a reason. It's an optical lens. If you take this dust cap off, and I mean, just like this, waving it in the air, there's a lot of dust in this air, right? You get dust, you get oil, you get grime on that lens. And let's face it, our work environments are not very clean. That happens, you're gonna disrupt lasers. You're gonna have loss because you have a dirty connector. So how do we clean that? Most people don't know that these exist. I blend them into all my trainings now. This is known as a pen style cleaner or click cleaner. You stick this into the connector, click it, puff of air, quick wipe of that lens, it's clean. Anybody who does fiber optic installations, these are like 50 bucks. Just buy one, okay?
Come with the kit?
They don't come with the termination kit because you buy these. There's two different sizes for an LC versus an SC style connector because these are two different sizes. So you can pick whichever one you want. Buy both. I just recommend if you have an installation where you have loss on that line, number one thing to check, make sure your connector's on. If your connectors are on properly, clean the lenses. Especially if you're going into a project where those fiber connectors have been installed by somebody else and they've been there for a long time, clean the lenses.
I got a property that the video doesn't work, but the internet does. They say that their media box is not getting enough light.
Oh yeah.
Just get one of those cleaners or replace the connector.
If you're lucky.
Okay.
This is super common. So it goes back to that link budget conversation. The link budget on video distribution over fiber is about 3 dB of loss. So equipment can handle about 3 dB of loss. Networking equipment has a link budget of 11 to 22 dB of loss. And that's just what happens when you have an intermittent connection with network. It just slows down. So it'll still work, it just slows down, right? What happens if you have intermittent connection with HDMI? The screen goes black, right? Yeah. Yeah, you lose handshake, you lose sync signals, doesn't work. That is considered a catastrophic failure, right? So in an installation like that, the first thing that you do, check the connectors. Second thing you do, you can clean the lenses, right? You can. But if it's older fiber, it goes back to what can happen is when they pulled that cable or when they bent it in the rack, you get microfractures in it. Microfractures spread over time. If it's not a polymer-based cable, those cables can degrade. And you will see the performance of the network. It'll still work because network, 22 dB of loss is a lot of loss. But it's going to spread, it's going to fall apart over time. That could be your issue. That is a very common issue that we see folks who are going into previous fiber installs. And the other thing that's just, it's a real issue, and it's not even the fault of the installers per se when they put that fiber in, because they pull it, they test it out, everything works great, they don't even know that there's a fracture in it, but it happened. That could very well be the issue. Okay, so that's really the other thing that we see in fiber optic installations. That's why, even a lot of companies that work with fiber today, they like this type of fiber because that doesn't happen. And then from there, clean, if your connector's on there right, if your connector's clean, if you know you got a good cable, well then you start to look at, the electronics, what are we doing? There's other things that can play into it. But for the most part, you will find fiber is a much more reliable mechanism provided those things are taken care of.
Good question.
Yeah.
Is there any easy way to tell the difference between the polymer fiber and the older fiber?
Yeah, if it says SSF, it's a patent. It'll say SSF grade.